With Booster 4 and Ship 20 reunited at the launch site, both vehicles will undergo proof testing and static fire tests, before becoming an integrated stack for the second time. Unlike the earlier mate, which was for fit checks, the next joining of the Super Heavy and Starship will be for the orbital velocity test flight. First, both Ship 20 and Booster 4 require proof testing ahead of a static fire campaign to ready the vehicles for flight. These objectives will be carried out amid continued work at the Orbital Launch Site, which is being prepared for Booster 4, Ship 20's flight and future missions, that will include using the Mechazilla system. Ahead of Booster 4's return to the Orbital Launch Site, and likely to continue for the coming weeks, preparations to complete and prepare Mechazilla hardware have progressed in situ next to the launch tower. These giant arms will be used for raising and stacking the Super Heavy Starship system, and eventually catching the duo during their return to the launch site. This, as per Elon Musk's recent tweet, could come as soon as Booster 5's return. With the structural framework of the quick disconnect arm already installed, the chopsticks for Mechazilla are set to be the last major addition to the tower. The QD and chopsticks make up the total of the Mechazilla system, given the QD arm also provides stability to the stack during mating options. A giant claw-like carriage structure has also been observed, which provides some insight into Mechazilla's design. However, the confirmed setup will only be known once all the elements have been installed. Another element, which is being fabricated at the production site, is another attachment for the QD arm. As per the setup of the launch tower, the ships will be supplied with propellants and other needed commodities, via the QD arm high on the tower. While the Super Heavy boosters will be fueled via the QD plate located on the launch mount. The other key element for the OLS's readiness is the tank farm, tasked with satisfying the thirsty needs of the world's largest launch vehicle. Numerous rollouts from the production site to the launch site have involved new ground support equipment tanks and their cryo shells, the latter used to insulate the GSE tanks, as they are filled with super cold propellants, ahead of supplying the vehicle. To this end, SpaceX finds itself in several tandem processing flows, focusing mostly on Ship 20's upcoming orbital velocity test. Currently awaiting its restacking with Booster 4 to become an integrated stack once more, workers have been busy replacing thermal protection system tiles on the nosecone area of the vehicle. This process has seen technicians replace several hundred tiles, denoted by the various colored stickers placed on the areas of interest. While the specifics of the color coding are not known, this does mirror the previous days of processing flows of shuttle orbiters, inside their orbiter processing facility, where the vehicle's TPS was maintained. However, the main difference between Shuttle and Starship is the pace of replacements, with Ship 20's taking days. Such a large-scale replacement took many months for the shuttle orbiters, as evidenced by similar TPS tile berthing issues with Shuttle Columbia in 1979. Once the TPS tile work has been completed, Ship 20 can look forward to proof testing, which normally begins before installation of Raptor engines. However, the three Raptors for Ship 20, SN 73, 78, and 69 rolled down Highway 4 last week, along with at least one RVAC. This could point to a refined timeline where Ship 20 will be pressed through propellant loading, before conducting the static fire test at the end of the process. Booster 4 likewise joined Ship 20 at the launch site when it rolled out of the high bay, on Tuesday before taking up residence near the OLS launch tower. Sporting all 29 of its Raptors, this was Booster 4's second trip to the launch site, the first marking the historic milestone of conducting fit checks as an integrated stack with Ship 20. It was not immediately known whether this mating on the orbital launch mount was just for additional fit checks, or if it marks Booster 4's pre-launch campaign. Options include dematting it from the OLM and conducting tests on Pad A. However, Elon Musk soon noted Booster 4 would be tested on the OLM. Booster static fire on orbital launch mount hopefully next week, noted Musk on Twitter, again with an ambitious timeline but with the important confirmation that Booster 4 is now a resident of the OLM for testing. Interestingly, while the focus remains on Booster 4 and Ship 20, the build-up for Booster 5 is already picking up pace. In recent days, the next Super Heavy sections have been spotted in the usual staging areas, outside of the production tents as a preamble to stacking operations. While numerous sections are without labels, one that did sport its identity was Booster 5's aft section. Positioned in the usual spot where sleeving takes place, Booster 5 stacking operations are set to begin imminently, with a common dome section for the next Super Heavy already moved inside the high bay, with the other sections lined up in the production site yard. Amazingly, the first section with a Booster 6 label has also been spotted, with NSF's Nick Answeeney. While the high bay is ready to support the next Starship duo, the mid-bay has hosted the final GSE tank, GSE-8, ahead of its own rollout. Ship 21 will now be stacked in the mid-bay before rolling to the high bay, for nosecone installation. Although Starship production cadence has been one of the standout highlights of the early years for SpaceX's Starbase, future production requirements require even more capacity. As confirmed by Elon Musk, additional capacity will come via an even larger high bay, which, in typical SpaceX fashion, has already begun construction to the north of the existing high bay. Slightly taller and much wider, this new high bay is set to host at least 2 Super Heavy stacking flows, removing a bottleneck should SpaceX's vision of multiple launches per week come to fruition. SpaceX's engine testing facility on 4,300 acres of land in McGregor, Texas, just south of the city of Waco, is undergoing new development and testing, related to the Raptor engine for Starship and Super Heavy. With 5 test bays, the facility will soon become a hub for Raptor 2 engine assembly, with a new factory now under construction. This is taking place as Merlin engine and stage testing related to upcoming Falcon 9 and Falcon Heavy flights continues. The McGregor facility, originally the location of the Bluebonnet Ordnance Plant, was used during World War II to manufacture bombs. However, Elon Musk has recently announced that a new production plant will be built near the McGregor engine testing facility. This plant will specifically produce Raptor 2 engines optimized for firing at sea level, most of which will be used on Super Heavy boosters. The Raptor 2 is a future version of the engine soon to enter testing, and the factory will be capable of making 2 to 4 of these engines per day. This production rate is higher than a typical rocket factory, but low compared to an automobile factory. As Elon stated in a tweet, the factory will be the highest output and most advanced rocket engine factory in the world. He believes it will be needed to support high-cadence Super Heavy operations, including many flights to Mars related to the build-out of the planned Martian city. The Raptor vacuum engines with larger vacuum-optimized nozzles, for use in space and high altitudes, that will only be used on Starship will still be built in Hawthorne, which will also work on unspecified experimental designs. Thanks for watching this video, and it's a super interesting topic. If you like this, make sure to subscribe. If you have any crazy ideas about what we should cover in next video, please comment it below, and we'll see if we can get to it. So thanks again for watching and goodbye.